Good. So welcome everybody. We're here today for the third talk of this series that European Bioplastics started. We will be talking about, in this series in general, about material solutions and all whatever is implying the application of bioplastics beyond packaging. So there is a lot of discussion on packaging already, but we would like to explore other products, other applications of bioplastics. We're talking today with two experts about consumer goods, and we will take a deep dive with Patrick and with Jorn. But first of all, I would like to introduce a little bit the format, so we're all on the same page, and introduce also European Bioplastics. My name is Chiara Bearzotti. I work for European Bioplastics. European Bioplastics is the association that has been working in the last 30 years for improving the regulatory and policy framework of bioplastics in Europe. We are a large network of more than 80 companies working on the topics. We've got some producers, we've got some researchers. So this is a broader network that is coming together under this kind of platform. We are funded for this specific format from the European Union. So just bear in mind that what you will hear today is not necessarily reflecting the opinions of the European Union, of European Bioplastics, and the authors are just responsible for themselves about what they report and their opinions and point of views. Few things that I would like also to explain. If you're here for the first time, we got one moderator, that's me. You got two experts today, so Jorn and Patrick. Their presentations will go around 30 to 40 minutes, and then we will have a joint Q&A. We recorded this event, so the recording is running. We will not record the Q&A, and you will get, in any case, all the different presentations, information, and references that we will discuss today, and the Q&A will be removed from the final recording. Now, the next appointments. This is a series that is running until July, at least for now, provisionally. 19th of May, we will talk about the applications of bioplastics in automotive, and on 16th of June in agriculture. And on the 7th of July, we're working a different angle on medicine and hygiene products, so medicine devices and hygiene products. And this is also where we have some of our members on board. Housekeeping rules. So we're trying to remove from this call AI tools. We don't want them necessarily in this kind of recording and activities. During the talk, you're already muted, but you can use actually the chat for asking questions by the time that the conversation is starting to warm up. So please use the chat for typing your questions also when they're rising, and then we will address them together during the Q&A. And to ask questions, as I said, the chat is our primarily tool, but if you need to kind of speak up and you would like to have a more in-depth conversation, you can also raise your hand, and we can also decide to change your status from attendee to presenter. So today we're here for consumer goods. We will have Patrick talking about toys and other technical products. And this is providing an overview of what bioplastic can achieve today. Jorn is coming with a different angle from a designer. ARAPAHA is a company that is working a lot with PLA. So we'll also talk about furniture and other consumer goods, and you will see his presentation as well with this kind of different examples. The next talk, this is going to be, as I said, on the 19th of May. We will have two experts from Stellantis and from the DIAD group, talking about components that are used in the automotive sector. Now it's time for your phones to come into the game. I would like you to scan this first QR code. This is an invitation to register for our annual conference in December, 1st and 2nd December in Berlin. And this is the meeting of the European Bioplastic Community. So join us if you're interested. This is the first QR code. The second one is a call for papers. So if you would like to present your own innovation, your own results, activities, products to the conference, send us a paper by the end of June, 30th of June. And this is the QR code that is leading you to the exact page where you can provide us with the details.
Yeah, good morning, everybody. Nice to meet you. Thank you for the invitation and give me the opportunity to talk here. As you maybe can hear, I have a little bit difficulty with my voice, so maybe I'll start coughing and need to stop for some seconds, so sorry about that. But it's typically, if you are going to have a presentation like that, you get a slight cold. That seems to be somehow common. Anyhow, so I would like to talk a little bit about the future of the biopolymers, also in the context of PPWR, because it's beyond flexible. I'm the managing director of the FKuR group. So we are a producer and distributor of biodegradable, bio-based, and also recycled materials, whilst we are going to expand in that business too. So that's very brief what we are doing. We are a typical mid-sized company, approximately 100 people in the group, 65 working in Europe, another 30 working in India. We are a compounder, so we are mixing PLA and starch and whatever kind of materials together to create respective compounds for films and also rigid applications. And we are also a distributor, and the main product that we are distributing is the bio-based polyethylene from Braskem, the lime green materials. Well, yeah, so our scope and our thinking is that we need to tailor materials respective to different regions and their existing waste management that is in place to date. And I mean, very simple comparison, if you see what we can do and achieve in Europe in terms of recyclability and also compostability. If we then have a look to my Indian colleagues, then of course the situation is completely different. But we think that all of those kinds of materials like the biodegradables and also the drop-ins and the recyclates and even the mass balances have, let's say, are a valid solution for, let's say, defossilization. Even if we see mass balance more as a bridging technology nowadays. But the main focus here is still the compostables and the drop-ins, as well as in combination with the recycled materials to obtain respective properties. Well, that's a short overview of our whole portfolio. As you can see, we are quite strong also in the biodegradable and bio-based materials based on PLA or based on starch. We are even using also some PHAs here and there. And then we have the non-biodegradable portfolio based on mainly on green polyethylene and also green EVA. And as I have said, post-consumer recycled materials are also now added to our portfolio in order to offer a very broad range to our clients worldwide. So if we talk about the durables and if we talk about flexibles, then of course we should also talk about what sustainability and circular economy means. And the main question that I'm asking is always, is that not the continuation of linearity? But because at a certain stage, we will create waste. That is, we don't have any other chance, I would say, because that's physics. We cannot avoid to produce waste at all. But when it comes to sustainability, and that's a kind of common understanding that we are mainly talking about CO2 reduction and CO2 neutrality, which is, of course, a very important point, no doubt about it. But sustainability in general is pretty broad. It's much more. It's about, let's say, renewable energy. It's about education. It's also about biodiversity, clean water, waste management, and so on. So it is a system that influence our daily life in a whole. So sustainability is extremely complex and not only linked to a simple CO2 reduction. The most effect in general when it comes to sustainability is to refuse products. It's just a question of how much do we consume and what we really need. And of course, that is the biggest leverage that we have in order to preserve resources. So therefore, even the PPWR will not help us in this respect at all. So refuse is one thing, reduce, let's say, material thicknesses, reuse, of course, or repair, as well as recycled, and later on, then also compostability as a part of it. The mainly kind of philosophic question that we need to answer whenever it comes to sustainability is, how sustainable can the first world or a developed world, as we call ourselves sometimes, can be? And this is a question that is very hardly to answer because our main problem is still the overconsumption. And that can not be, let's say, solved with any kind of legislation. And this is just this very nice, maybe also inconvenient draft. How our consume looks in average globally. We have one globe, and in average, we consume 1.75 globes a year on the whole. But if everybody would like to consume as much as Germany is currently doing, then we would need at least 3 globes to achieve the same standard of living. And this is exactly the difficulties we are facing. So the planetary boundaries is something that we need to consider and we need to live within. And circularity alone will definitely not solve that problem, nor will that be done by the PPWR or any other legislation. That is what we should definitely keep all the time in mind. So it's good that we think about what can we do with our waste, what can we do in order to get fossil free. But the biggest leverage is, of course, to think what will be happen with the overconsumption and taking into consideration that countries like India, China, and even Brazil would like to achieve, and the others as well, achieve the same level as we've got here in Europe. So that will be a very interesting development for the next years, how we can handle that. Now, if we come back a little bit to what is happening in Europe and having a look on the PPWR, then of course recyclability is a very big topic. And this topic is so strong that we of course need to understand what does that mean for compostable materials. But what we also need to understand is pretty much clear that it doesn't matter what we are doing, we are producing always waste in terms of material losses, but also of course of exhaust gases and heat. That's thermodynamics. I'm sorry to say, but this is something we cannot, let's say, stop. And when we see what we are coming to do, I mean, chemical recycling, mechanical recycling, even organic recycling should be treated on the same way, because they all have a kind of priority, and they have also, let's say, they are very important for the circular economy. But it all depends on the input stream and the way of sorting in order to reduce the material losses and to get a better, let's say, recycled material out of it, which we bring into the market. The same applies for organic materials. As better and more organic materials we are sorting and collecting, we get better compost, which we can bring back, let's say, to the nature, but also can use somehow in a bioeconomy to produce chemicals out of it that can be then reused for, let's say, compostable materials or bio-based materials. For chemical recycling, it's sometimes even difficult because here the yield depends significantly from the input stream. And also that means sometimes, what I'm hearing in the market is, they can use the mixed plastic that is available. That might be nice that the chemical recycling should use all the plastic that is hardly to mechanical recycle, but even that would then lead into quite a lot of material losses, because the chemical recycling industry would also need a very clean input stream in order to be efficient. So this means, very broad, very general, we need to increase the collection of materials. We need a higher quality in sorting and a higher quality in processing, and only then we will create a greater circularity, irrespective if we talk about, let's say, plastic products, or if you talk about organic waste. And when it comes to organic waste, then of course it's pretty much clear, when we would have a mandatory use of compostable materials in the EU, we would collect more organic waste that we can use as sources. The takeaways from the PPWR, and then later on I'm coming then to the opportunities besides the flexible materials, but there are some critical points which is not only linked to compostable materials, but it's pretty much clear that the recycling is a key mission, because before that we even exporting our waste. And since we are not allowed that anymore, we need to think about what can we do with our waste now before it then will finally incinerated or even landfilled. And then of course, recyclability is one thing to keep the material much, much longer in the loop. But, and that is a but that is quite important, especially for the last point that I've mentioned there, the view is mainly on existing biopol or polymer solutions and too little opportunities for new and innovative materials. And the biggest threat in that is the term recycling at scale. And recycling at scale would mean that at least per country, you would need your 5-digit number that collection and recyclability makes sense. Of course, we are working there on solutions, especially for the compostable materials, but this is for sure a term that is quite critical whenever it comes to material innovation. And definitely, even that is now changing a little bit, but there is too less promotion for bio-based and renewable resources. That's quite clear. And even in my personal opinion, there is a limited understanding of the importance of organic recycling and using organic raw materials for the bioeconomy. So what kind of solutions do we have today, or what can be done out of biopolymers, aside, let's say, the typical flexible applications, because that they are so nice because it's a very nice volume. But in the rigid market, there is also a lot of chances. And whilst I'm talking a little bit about toys in general, I would like to show you some examples that we developed together with our clients, also from a polymer modification point of view. This is a product which is then for children dining equipment, and there were quite a lot of work that was be done, because that was also developed from PLA-based materials, and then we turned back to a partly bio-based PP compound, because the client needs some respective properties like scratch resistance, but also heat resistant, and that was quite difficult to achieve with a bio-based but still biodegradable material. And so we modified it respectively so that the client can use it also in terms of, let's say, to use respective additives for the colorization. But regarding scratch resistant, elongation and break, but also stiffness, we even tested the material in dishwasher and microwave, which was then approved by an official test report. But this is not an easy task to overcome, because it looks like a simple product, but finally it's still quite complex in terms of the requirements. That product was maybe here and there seen already. It's the bricks from BioBody, which is an alternative to the typical Lego bricks that everybody knows. But in this case, we made it on a tailor-made compound for also from a bio-based polyethylene. And even here we tried, of course, we can never replace ABS with that material. That's pretty much clear, because ABS is a very nice material in terms of durability, heat resistant, stiffness. But whilst we have used a bio-based compound, of course, the material has its own haptic and its own behavior, which is also a kind of unique selling proposition for that client. And to be honest, it's even still recyclable, because it can enter any, let's say, polyethylene recycling stream. But this is a 100% bio-based polyethylene material that is now in the market for, I think, nearly 8 years now. That time, the client was mainly looking for a bio-based alternative and to widen its portfolio. And he, of course, invested quite a lot in a transparent communication. What is inside, how it is measured, how much bio-based carbon content is inside. This product is quite a success. This is another compound for a kind of puzzle, if you like, or jigsaw. But it's a construction part, which is also not quite easy to produce, let's say, from a compounding point of view, because the material needs to be robust and durable on one hand, but also flexible. And here also the client wanted to have a bio-based and then a recyclable solution. I mean, here we tried that with also PLA-based materials, but then we decided that, let's say, a bio-based drop-in solution would be a better solution in terms of the properties that should be achieved. We also made some reusable cups. In this case, they were made from a PLA blend, which we also tested in dishwasher and food safety, but also for microwavable applications. The good thing is here, I mean, the main focus is that the product itself should be durable and reusable. And while PLA could be the question, well, in this case, it's also because of the haptic and let's say the durability, and then also how the touch and feel of the product. That was something that the client was looking for. For sure, in that thickness, it will be not, let's say, compostable, but the biodegradation is, of course, given. For sure, what we definitely see in the near future is that biodegradable plastics should be used in application in the natural environment where the plastic remains to date in nature because it will be not collected. So that can, of course, be any kind of product that remains in nature, let's say for forestry and so on. Mulch film is for sure the main common application, which is in the market since, I would say, 20 years, even longer. But of course, there are quite more applications available. And there, of course, biodegradable materials provides an added value, which none other materials will provide today, because normally in such application, mainly polyprop, for instance, is used, which is then definitely not collected. And so, of course, here we have the opportunity that the material, which will break down, which will get brittle, which will create small particles, that those will biodegrade in a certain time frame without, let's say, remaining microparticles then at the end. And last but not least, this is for me still one of the perfect solution when it comes to the packaging waste regulation and monomaterials, because normally those kinds of bottles are made from 2 to 3 different materials. The bottle itself is mainly made from an HDPE. The label is made from a polyprop or PET, and the cap is mainly made from a PP copo. In this case, the client decided to make all 3 different product categories from one material. So it's a monomaterial. Even the cap is made from a green PE. Even the label is made from a green PE. And that means this is 100% recycled material. It's 100% bio-based. And interestingly, even the end clients do not feel uncomfortable if the cap is not remaining anymore on top of the bottle. So even that is working and widely accepted. And of course, it contributes also to the organic product, which is covered in the bottle itself. Short summary, what are now the core principles? For sure, sustainability in a conservative sense means waste prevention. So living within the planetary boundaries, which is quite difficult, of course. Consumption is something that needs to be reconsidered. And if you want to really consistent close the carbon cycle, this will be only possible with bio-based materials and organic resources with regard to the bioeconomy. For recyclability in general, which is to date the main driver in Europe, it must be significantly increased, both in quantity and in quality. And of course, we need to sort much better than to date. And we think that biodegradable materials should be used wherever biodegradability provides a significant advantage because of the intrinsic property that the materials can remain, for instance, in nature. So thank you very much, and awaiting your questions later on.
Good morning, and thank you very much for this invitation. And I'm Jorn Behage from ARAPAHA from the Netherlands, and we are fully involved in the application of biomaterials in several types of products. I will focus more on the designer perspective today and show what you should know or what you should think about when you're working with PLA or PHA or whatever. This is a small photograph of my of our research department, where we do the knitting tests with PLA yarns and so on. Okay, next. Well, what we try to do is to reduce the environmental impact of products as much as possible. And what you see is it's a part of a carpet that we developed and which is fully PLA. So the top layer and up to the bottom, it's inclusive the glue. It's out of PLA, and so we have a 100% PLA product that we tested in Belgium at Centexbel, and it passed every test that it's needed for home applications. And we even used for the dyeing, we used the supercritical CO2, which is a dyeing technology without water and chemicals. So we have the most cleanest way to produce this kind of carpets. Next. Here's what you see is the effect on when you use a fully PLA carpet compared to a conventional polyester carpet in the market. When you have a size about 240 by 170 meters, then the amount of CO2 emissions are about 89 kilogram per carpet. With polyester, and when you do it in PLA, it's about 25.1. So that gives you an indication about a huge advance that you could have with biopolymers in general. But now we will go more into the what's really needed to do it right. Next, please. So the key design requirements is that you need a fundamental knowledge about the molecular structure of PLA or PHA and so on, because when you look at the PLA, you have two types of molecules within the material, and if we call it right and left turning polymer, and then or PDLA or PLLA. And if the PDLA is above 5% amount in the material, then you see that the recycling is a problem. So you have to deal with this kind of problems when you are designing a product. Of course, you need a lot of knowledge about additives and dye technologies, especially how they behave in the recycling processes. When you do a chemical recycling or mechanical recycling, they can interfere the process quite a lot. But if you do it right, then it works. What we also do is about sustainable product technologies. We look at technologies that use as less energy as possible, and also at less as residuals in the process as possible. So trying to work with environmentally friendly technologies, energy efficient technologies, is also a key part of the whole design approach. Of course, the digital twins in packaging or products is something that should be standard for each designer to calculate. And of course, you have also the limits of aesthetics. You cannot do every kind of aesthetics with biomaterials. You have to know that. So it's sometimes you cannot replace one material by the other and expect the same result. And the end-of-life concept is fully integrated in the design process, which is also a very complex system because it can change by country. So the ideal recycling process for biopolymers could be different in Germany or in the Netherlands than in Spain or somewhere in Asia. Next, please. So to give you a little bit idea about when you talk about packaging, this is about the recycling approach that you do. On the left, you see tea bags, which are using PLA. It's about 0.3 gram PLA in a tea bag, which means that it wouldn't make any sense to do chemical recycling of tea bags. That with 0.3 gram is too little. But composting is a very good approach for this. In the middle, you have these bags that in PLA, and there it makes sense to think about chemical recycling because it is easier to shredder and recycle as such. On the right, you see an application that I have my doubts because it gives me the feeling it's kind of greenwashing. It's a packaging for a tennis racket, and a tennis racket, you know, it's carbon fiber or glass fiber or whatsoever. But and then to make a fleece out of PLA and to wrap up the racket, that's not the way to go, in my opinion. Next. Yeah, this is a recent development that we did with our knitting machine, where we test PLA material. And this is a kind of a little bag for soap. And what we achieve is that with the PLA we can steer the application in such a way that it's the whole pack scrubs well on your skin. So it's a very good way to clean your body. And PLA doesn't absorb too much moisture. So when you don't use it, it dries out quite quickly, and so there is no formation of fungus and so ever. So this is something that where you use the real functionality of PLA in a product, and this is something that as a designer you should understand very well. Next, please. So this is what I talked about before. This is our carpet project where we were dyeing the PLA with supercritical CO2, and which works quite very well because the technology was developed for polyester, and PLA is a biopolyester as such. So the dyeing technology works perfect for biomaterials, and it's a process where you don't have use any water or any chemicals to dye the product. And the only thing is that you have energy consumption, but the whole LCA calculation in this technology is that this one is 50% better than the conventional way. So this is a step forward into sustainability as well. Next. This is one of our projects that where we just wanted to show what were the limits by then of what we achieved with PLA developments, which is the back is made out of a fleece in PLA, and it contains also some injection molding parts, and where we achieved quite good results, and even a little slightly better than ABS properties, and so it was a very good result that we learned how to do that, and it's a natural additive that we put in, and it has no impact on the recycle process as such. Okay, next one. And this is our recycling testing that we did. So we put the whole bag, we shredded it into small pieces, and then we did a partial hydrolysis where you get an oligomer, then you get a distillation, get your lactite, a crystallization, and then you get at the end a polymerization again. So you can go to the whole process from post-consumer PLA and create a new PLA out of it. And the process were done by us, the whole cycle, and the results were good enough for the next generation. Next. This is the comparison also that as a designer or as an entrepreneur you have to know very well is that when you compete with all the other fossil-based plastics, that they have a quite low price compared to PLA, but with the changing legislation in Europe, the situation could be changed quite rapidly. So we expect that there will be a tipping point in 2028, where PLA will be more competitive compared to the other plastics. Of course, this is just a measure from one moment, and if you do the measure every month, then you will see the slightly difference because the price goes up and down. But it gives you an idea that when we get into the new European legislation, then the bio-based materials will have an advantage in behind 2028 and so on. Next, please. So the main challenges that we can do is look very carefully at material performance. And then with and without additives. You have to know what you are doing in this field. And the production technologies, the embedded energy of a product, you have to know what it is, how much it is, and when you make a design decision, what is the effect at the end. Then, of course, at the end-of-life concept, recycling or composting, you have to decide which way is the better way, and then design the product in such a way that it fits into the right process. And of course, all you have to compare the costs to current materials now and in the future, and make your decision based on that too. That's common sense for companies. Another very important point is consumer behavior. Consumer behavior is a key issue when you want to achieve sustainable products in a broad market. And so you need to understand what are the triggers for consumers to behave in a sustainable way, and then adapt your communications, your marketing and your sales communications towards that goal too. And of course, the European and national policies on fossil-based materials against biopolymers is also a very important thing to monitor very deeply, because that makes a lot of give us a possibility to analyze very well when biopolymers will have the in the market at the right position. Next, please. That was it within the time scale. So thank you very much for your attention, and I'm looking forward for your questions.